Last few class I have started design of foundations, and first one I have started shallow foundation. I have completed for shallow foundation in sand. Just recap. So, where I was there in last week. So, shallow foundation in sand, we have considering say bearing pressure, considering bearing capacity, as well as soil bearing pressure considering settlement, and from there for a residential building 25 mm settlement, industrial building 50 mm settlement. So, allowable soil pressure is your kilonewton per meter square, and it has come with your 10.5 N as well as 21 N. Then correction factor, water correction factor, water table correction factor also I have discussed. Then why we are going to take N cumulative average? N is your SPTN value has been taken, and cumulative average value, because the intermediate values could be taken from the plot rather than interpolated interpolations, and it reveals relative position of N at various depth. That is the advantage to take N cumulative values. Then I have solved a one design problem. There is a building, in that building one interior column, then another one is your exterior wall, dead load, live load is given. There are two borehole data. Borehole 1 is nearby from the interior column, borehole 2 is nearby from your exterior wall, and this design has been made and nothing has been assumed. We design considering where we are getting a consistent value of SPTN from the cumulative average. Based on that, that part your pressure bulb will come into picture. Based on that, your depth of the foundation has come into picture. Then from there your foundation size comes into picture. This is what we have completed this design, and we have calculated this, what is your net load intensity, all details, wall footing as well as interior column we have calculated. Now next come to loads for the design. So for structural design, generally we take it dead load, and it is your maximum dead load and absolute maximum live load. So structural design we are considering dead load and absolute maximum live load. If you look at here, this can occur in a life of structure corresponding of the duration. This can occur in life of structure. This also equally applicable to soil design in sand. So in case of clay, if you look at in case of clay, it is a time dependent. That means that is your consolidations, and it can be applicable to sand. If I draw simple way, this is the load and there is a time. So this is my dead load. Dead load means the constructions self weight even if it is residential building, whatever the dead load is there, permanent dead loads, that has to be there. Then look at here, this is called RLL. RLL is called reduced live load, and this is your this peak, particularly here, this is your MLL. If I say RLL, reduced live load, so it is a major part of the structures, live load acting for the major part of the life of the structure. Then there is a possibility, so sometimes maximum live load may occur in nature, it is a kind of pulse acting. MLL is your maximum live load, it is a very short durations, So these are all we want to consider. One is your dead load, one is your reduced live load, and third one is your maximum live load. So generally what happen? Generally factor of safety is 3 generally taken on net ultimate bearing capacity, considering RLL, that is your reduced live load, and factor of safety is equal to 2 on net ultimate bearing capacity, considering maximum live load. So if I say if net load intensity NLI, we can call it as safe bearing pressure. So I can write it net load intensity considering dead load plus reduced live load, which is equal to net ultimate bearing capacity divided by 3, then net load intensity considering dead load plus maximum live load, which is your net ultimate bearing capacity divided by 2. Now if I put it net load intensity dead load plus maximum live load divided by net load intensity dead load plus reduced live load, which is equal to 3 by 2, which is equal to 1.5. So what does it mean? Net load intensity under dead load and maximum load is 1.5 times more than net load intensity under dead load as well as dead load plus reduced live load. So this is what loads for design, particularly structural design, you have to consider in future. So while designing, you consider, if you are considering dead load and reduced live load, then you take factor of safety of 3. If you are considering dead load and maximum live load, you consider factor of safety of 2. So this should be taken care. Now next part come to here, that is your shallow foundation in clay. Earlier I have finished shallow foundation in sand, now shallow foundation in clay. So if you look at this formula, QU is equal to ultimate bearing capacity CNC plus gamma DF NQ plus 0.5 gamma B N gamma. For phi is equal to 0, phi is equal to 0 means there is no cohesion, it is purely cohesive soil, that means N gamma is equal to 0. In that case QU is equal to CNC plus gamma DF and QU net is equal to CNC plus gamma DF minus gamma DF. So, this will go, this will be only CNC. If I take into C undrained cohesions, so that means QU by 2 into your NC. Now, Q net safe is equal to QU NC by 2 into factor of safety, which is equal to, if I take factor of safety is equal to 3, this is your QU NC divided by 6. So, Skempton has given NC, Skempton says NC depends upon your B by L. So, if I plot it NC versus your DF by B, this is your NC, this is your 0, this is 1, this is 2, this is 3, this is 4 and this is 5. If I put it here, it is 6, then 7, then is your 8, then is your 9, so here it will start from 5. This will be your B by L is equal to 0 continuous. This is your square or circular where B by L is equal to 1. So, this part is your DF by B. DF depth of the foundation, B is equal to your width of the foundations. Now, if I write it NC B by L greater than 0 less than equal to 1, which is equal to NC B by L is equal to 0 into 1 plus 0.2 B by L. So, that means Q net safe, which is equal to QU NC by 6 into 1 plus 0.2 B by L. So, if everything is constant, suppose B is constant, L is constant, NC is also there, what will happen? This is your soil bearing pressure. That means SBP is directly proportional to your QU. So, NC for surface, how much the value of NC for surface? NC for surface is equal to pi plus 2, generally it is 5.14. So, QU is your, it is directly proportional to your QU. If I put it in terms of graphs, let me put it. This is your SBP, kilonewton per meter square, and this is your QU, kilonewton per meter square, and this will be varying that means it is starting from dF by B is equal to 0 to 2. So, shallow foundation is clay. Let me revise it. If you look at this, what is there, QU is equal to CNC plus gamma dF NQ plus 0.5 gamma B N gamma. For purely cohesive soil, phi is equal to 0, that means N gamma is equal to 0, then QU is equal to CNC plus gamma dF. So, Q net is equal to CNC. C is your undrained cohesions, that means is your undrained cohesion is nothing but if I go to there, that means QU value, QU is your, if I go for a unconfined compression test, from there you can find it out the value of the QU. So, here if I go it, then this will be your QU by 2, this is the value of your C. So, it depends upon Q net safe, which is equal to QU NC by 2 into factor of safety. Factor of safety I put it 3. So, it is your QU NC by 6. So, Skempton has given a chart for NC. NC is what? Bearing capacity factor for cohesions, and NC versus dF by B. If I look at your NC at the surface, how much Skempton has given, this is your 5.14. So, it will be for B by L continuous, then for square and circular. So, NC for square and circular, NC for B by L is equal to 0 into 1 plus 0.2 B by L. Now, Q net safe is your QU NC by 6 into 1 plus 0.2 into B by L. So, this is called your soil bearing pressure. Soil bearing pressure is directly proportional to undrained strength QU. So, if I plot soil bearing pressure with your QU, that means this is varying dF by B is equal to 0 to 2. Either you can utilize the chart or you have a strength, value, from there you can find it out your QU. So, basically for shallow foundations in clay, safe bearing pressure is directly proportional to your QU. Let us start with this. What are the steps? Generally what will happen? QU you should take average value, look at here, average value under the footing to a depth equal to its width. Suppose this is the case, this is my depth, this is the variation of QU. I should consider the way we have done for foundation design in sand. I should consider in such a way that I should place the footing in such a way that the pressure bulb should cover in a range where strength will be slightly or higher side. That means from here to here, if I take the QU average, and if I compare this QU average over this range, I can say that okay, this depth is absolutely fine for foundation design. So, this depth will be considered as a zone of influence or pressure bulb. So, considering with this zone of influence, then your footing size will come into picture. Once footing size will come into picture, zone of influence will come into picture, what else left? Your left is your depth of the foundations. So, nothing has to be assumed here, like other books they say assume some footing size, assume the depth of the footing, it is not there, nothing has to be assumed, it will be based on your QU average. So, what are the procedures or what are the steps while designing? We will solve a problem also. First one, assume ASP, allowable soil pressure, which is equal to soil bearing pressure. Then step 2, find B. B is what? Width of the foundations. Find B from area. That means B is equal to wall load per meter divided by your QU for wall footing right. Then step 3, check net load intensity whether it is less than soil bearing pressure or not, right. Here either wall load meter per QU or it will be column load divided by QU into shape factor. If it is not satisfied, if not, then modify the value of B, till it satisfies these conditions. Then step 5, using net load intensity, find delta P. Delta P is what? Increase in stress, I have covered it because of your loading. Then rho, consolidation settlement. Then step 5, step 6, check settlement should be equal to permissible settlement. This also I have given very beginning foundation design as per your Bureau of Indian Standard, what is the permissible settlement of a foundations or footings, depending upon whether it is residential building, industrial building or maybe high rise building I have given. Even if I have also given what would be the permissible differential settlement also. So, that you can check from my earlier notes. Then if satisfied, then adopt your B. Again, if I come back to here, if rho is greater than rho permissible, then increase B, find net load intensity, delta P and rho consolidations. It will go and repeat it again from here. Then modify B till your rho is less than equal to rho permissible. So, let me summarize and slightly explain it. So, while solving the problem, afterwards we will solve one design problem that will be better for your understanding. What it says, assume allowable soil pressure is equal to your soil bearing pressure. Soil pressure considering soil bearing pressure, that means your settlement, from here soil bearing pressure where it is your QU average has been taken. Then find B from the area. B is equal to wall load, if it is a wall part design is there, wall load per meter into QU for wall footing. For columns, it is column divided by QU into shape factor. Shape factor is what? 1. Here I have discussed, this is nothing but is your shape factor depending upon circular, rectangular or whatever. So, it is 1 plus 0.2 B by L. Then check your net load intensity. Net load intensity is what? Net load intensity, foundation load is coming minus your self weight of your foundations, whether it is less than your soil bearing pressure or not. If it is okay, then that B is fine. If not, modify the B till you are going to get your net load intensity is less than soil bearing pressure. So, use net load intensity. Once this is fine, second step, this is, I can say broadly, this is your first part, this is your second part. Second step, using net load intensity, find it out delta P. Delta P is your increase in stress. Depending upon your footing size, whether it is rectangular, square or anything else, find it out increase in stress. That part also I have covered. Then find it out row consolidations. Row consolidation is what? Consolidation settlement, which is equal to Cc by 1 plus E0 H log 10 P0 plus delta P by P0. Then correction factor for water, if it is normally consolidated, over consolidated, that is there. This part also I have covered. Then find it out actual settlement, how much it is coming below the foundations. Then compare your actual settlement with your permissible settlement. For residential building, permissible settlement is 25 mm. It is for your residential. If it is coming, rho is less than rho permissible, that is fine. That means whatever you have taken your B based on your QU and water table, that is absolutely fine, and you can recommend that has to be done in actual field. If it is not there, suppose rho, that means your settlement calculated is greater than settlement permissible, then increase B, then find net load intensity, find delta P, find your rho cumulative, then it will go back to your original positions. So, you do it, modify the B till you are getting rho is less than equal to rho permissible. Now come to next, this is what I explained. Let us start with a design. What is the problem it is given? One of the example. Example is given, this is your ground surface, there is a load, column load, it is dead load plus live load, which is equal to 510 kilonewton, and there is a 0.3 meter, water table is acting at 0.3 meter, and given gamma is equal to 17.2 kilonewton per meter cube, G is equal to 2.72, water content W is equal to 41%, liquid limit WL is equal to 64%, and at the same time QU value is given, it is a 0, 50, 100, 150, QU is equal to kilonewton per meter square, then this is a 0, then this value is given. It will be very difficult to plot up to this scale. This is your depth. So, here to here this is your 6.5 meter. The average value QU average is given 76 kilonewton per meter square. Maximum settlement is also given. Maximum settlement is given 150 mm. It should not, maximum settlement should not greater than 150 mm. Now design it. It has been asked. No assumptions. Here look at here, like in most of the book, if you say okay fine, you assume the depth of the foundation, you assume the width of the foundation, no assumptions. So let us start with column load. Column load is equal to 510 kilonewton, it is given. So B is equal to column load 510 divided by Q average into shape factor, which is equal to 510 divided by 76 into 1.2. If you look at here, what is your shape factor? 1 plus 0.2, 1.2, B by L is equal to 1. So this comes out to be, area is coming. So column load is there. So from there, this is not a B, this you can say that B by B or area, which is equal to 5.59 meter square. So considering 5.59 meter square, then you consider area, which is equal to 2.4 meter by 2.4 meter. This is your B, this is your B. So area is coming out to be 5.76 meter square, which is greater than 5.59 meter square. Now what will happen? Now this is the pressure bulb, will be 6.5 meter. Within this pressure bulb we are getting the good strength 76 kilonewton per meter square. Then what will happen? If this is 6.5 and this is 1.8, total will be 6.5 plus 1.8, 8.3. So obviously what will happen, once I am getting up to 6.5 meter depth, good range, then obviously your depth of the foundation, obviously it is coming. So depth of the foundation is coming 1.8 meter. So dF by B, which is equal to 0.75, dF by V is equal to 0.75. Now come to this chart, you have to calculate also NC. I have given, Skempton has given, you can keep this chart for your examinations. So taking into dF by B 0.75, NC is equal to 6.2. Now find it out, what is the QU safe? That means SBP, soil bearing pressure, which is equal to QU NC into 1.2, it is your shape factor, divided by your 6, which is equal to 94.24 kilonewton per meter square. Now if there is a footing, this is my footing, So, this footing B is your 2.4 meter by 2.4 meter, and depth of the foundation is your, it is clear, 1.8 meter, and load is coming like this here. Then what should be my D? This size. This size as per your IS code, minimum value should be 0.4, because as per the IS code what it says, if this is the case, then there should be clear cover for your reinforcement. So, minimum value they have recommended 0.4. So, assume D is equal to 0.4 meter. Then you have to find it out, allowable load intensity. Allowable load intensity, that means ALI, which is equal to 510 divided by 510 is your column load, 2.4 into 2.4, which is equal to 88.54 kilonewton per meter square. Now, additional, it is a allowable load intensity, additional because of this, additional will be .4, right, into 25 minus 17.2, taking into consideration of 0.4. So, this will be 3.12. So, your net load intensity will be 91.66 kilonewton per meter square, which is less than 94.24, then this is your OK. Now, step 1 is over. Once step 1 is over, then your size is 2.4 by 2.4 meter. Come to the second step, settlement calculations. This is your ground level, and there is a water table here, and this length is your 0.3 meter, and there is a footing here, and the size of the footing is, this is your 2.4 by 2.4 meter, and this is your 0.4 meter, and this part is your 1.8 meter, and total will be your 6.5. Sorry, here it will be your total from here to here, total is your 6.5 meter. Now, then the pressure bulb is coming up to, here is your 4.8 meter, this is your 4.8 meter. So, half will be, this will be your 2.4 meter. Now, we have to check, sorry, 6.6 meter it is. We have to check settlement is fine or not. Now, Cc is equal to 0.00964 minus 10, WL minus 10. WL is 64 is given. Based on that, Cc I am getting 0.486. Considering degree of saturation is equal to 1, E0 is equal to G W, which is equal to 2.72 into 0.41, which is equal to 1.12. Now, H is equal to 6.6 minus 1.8 meter, which is equal to 4.8 meter. So, this is your 4.8 meter. So, at the mid depth below the footing, at the mid depth below the footing, P prime is equal to 17.2 into 1.8 plus 2.4, which is equal to 70.52 minus water table is there 10 into 2.3 plus 1.8 minus 0.3 floor slab, which is equal to 38.00, which is equal to 32.52 kilonewton per meter square. So, net load intensity is equal to 91.66 kilonewton per meter square. So, net load is equal to 91.66 into 2.4 into 2.4, which is equal to 527.96. So, now you have to find it out what is the delta P at A. This is either you can do it by 2:1 distributions or square footing, you can do it exact solutions. So, delta P at A, this is my point A, delta P at A comes out to be 23.90 kilonewton per meter square. This is what I am giving you, you can check. So, consolidation settlement is 0.486 cc by 1 plus E0, that means 2.12 into your 4.8, this is your height, then log 10 32.52 plus 23.90, P0 is your 32.52, delta P0 23.90 by 32.52 into 1000, which is equal to 251.7 mm, greater than 150 mm. If you come back here, stage 1 has been satisfied, stage 2 has not yet been satisfied. Now, if I go here, then what will happen if it is not satisfied? Then it is not okay. Then modify B value. So, then B value has been increased from 2.42, it has been increased 4.45 by 4.45 meter, so that the settlement criteria has been satisfied. More I will explain in the next class. So, what I have done, I have solved one example, whatever the steps I have described, step 1 and step 2. With this example, my step 1 has been satisfied and I am getting a size of 2.4 meter by 2.4 meter. Then at the same time settlement criteria has not satisfied, hence the value B has been modified to 4.45 meter by 4.45 meter. Considering this, then entirely all calculation has to be carried out. We will see, we will discuss more in the next class. Thank you.